Good day once again, and then today we are doing part 2 of the trig identities. So part 1 ended at example number 15, and I hope you tried those 3 sums that I gave you. And then now we are heading to example 16, which will then start to form from part 2. All right. Now, we need to prove that the left equals to the right, like we did with the first one. Addition and subtraction of fractions are dealt with by finding the LCD and then the following algebraic procedure. So because we're dealing with fractions that had additions and subtraction, we are going to do more of the LCD. So let's try to prove the first one. Remember I said you choose the side that has more information. So I'm going to choose the left hand side here, which is 1 over 1 minus sine theta plus 1 over 1 plus sine theta. This is the side that you've chosen. Now from there, I need to find the LCD. There's nothing much that I can do. Remember LCD, you are trying to make the denominators to be the same. You're trying to make the denominator, remember this is numerator, denominator, numerator, denominator. We're trying to make the denominators to be the same. All right, so for me to make the denominators to be the same, the LCD for this will have to be 1 minus sine theta, because this already has that 1 plus sine theta. So this side, I will have 1 over, this is 1 minus sine theta. Again, I already have sine theta, so I need to introduce this percent. So I will multiply this by 1 plus sine theta over 1 plus sine theta. Then I have a plus. This is plus 1 over 1 plus sine theta. Because of this side, I already have the plus 1, so I'm going to multiply by 1 minus sine theta over 1 minus sine theta. So this becomes like in your brackets, because it's 2 numbers and it's one thing. Good. Now it's 1 times that. So 1 times that will still be 1 plus sine theta over, this will be 1 minus sine theta, 1 plus sine theta. This is plus this addition. Multiply 1 minus sine theta is what you're left with, and then 1 plus sine theta, and then 1 minus sine theta. Now you do the normal algebra processes. So here at the top you still have 1 plus sine theta. The denominators are the same, so you can add now. Plus 1 minus sine theta divided by, when you add fractions, you keep one denominator when they are the same. So I'll keep 1 minus sine theta over 1 plus sine theta. Now when you look at the top, the sign will cancel the sign. You're left with 2 over. You really can see what you need down there. So we multiply this out. 1 times 1, I get 1. 1 times this, I get positive sine theta, and then this minus sine theta, then this we get negative sine squared theta. Now at the end, this is 2 over 1 minus sine squared theta. Now remember, 1 minus sine squared theta is the same as cos squared theta, and then this is the same as the right hand side. We go to number B. Number B, you are having the left hand side again has more information. You have sine squared x plus sine squared x. Let me just multiply by a tan squared x. It must be the same as tan squared x. So the first thing that I will do here, remember like we did in part 1, we changed the tan. This will then be sine squared x plus sine squared x times sine squared x over cos squared x. Are we clear with that one? Now, because it's a fraction, this is one thing, right? It's one thing. This is another thing. So cos squared is the LCD. So LCD equals to cos squared x. So I'm having sine squared x over 1. I'll times that by cos squared x over cos squared x plus. This side already has, what is this? The cos squared x. So I don't need to do anything to it. I can just multiply. You have sine squared x times sine squared x over cos squared x. Now from there, when you do the top part, you'll have sine squared x times cos squared x plus sine squared x times sine squared x. So you can make it sine to the power 4x over cos squared x. Now once we are here, we can take out a common factor. Remember, sine squared x, you're left with cos squared x plus sine squared x divided by cos squared x. Now this we know that is equals to 1. So I have sine squared x multiplied by 1 over cos squared x. And then this is tan squared x. Then you're done. Which is the same as the right hand side. Let's go to example 17. I don't know if I gave you guys enough time to check this, but you can always pause the video and you write the stuff down. And example 17 now, I have tan theta over sine theta minus sine theta over tan theta, and then that the left has also more information. So I have tan theta over sine theta minus sine theta over tan theta. The only thing that I can do here first is to change my tan. So this will then be sine theta over cos theta divided by sine theta. I said avoid doing double division. Minus sine theta divided by sine theta over cos theta. Now this is the same as sine theta over cos theta times 1 over sine theta minus sine theta times cos theta over sine theta. This will cancel that. This will cancel that. This side I'm left with 1 over cos theta minus cos theta. It's like over 1. Now the LCD will then be cos theta. I multiply both sides. Sorry, this is cos theta, so it's fine. I can say cos theta over cos theta. Now I have 1 over cos theta minus cos squared theta over cos theta. Now your denominators are the same. Keep one denominator. You have 1 minus cos squared theta. 1 minus cos squared theta will give you sine squared theta over cos theta. Alright, this is the left. Now, I can also work something out on the right there. The right hand side is tan theta sine theta. I know tan is sine theta over cos theta multiplied by sine theta. Now I cannot cancel sine because they're both in the numerator, so this will multiply. This will then be sine squared theta over cos theta, which is the same as the which is the same as the left hand side. So in this case, I had to do the left and also do the right. And then these are the kind of question we are expecting in the exam, to actually do both sides most of the time. Number B. We are having 1 plus tan A over 1 minus, sorry, why is it running like that? Sorry about that, guys. Oh, let me try to do this. Just erase. Let me look for the question. Okay, it's 1 plus the tan of A over 1 minus the tan of A equals to the cos of A plus the sine of A over the cos of A minus the sine of A. All right, in this case, let's take the left again because I can change something there. The left hand side, 1 plus tan A over 1 minus tan A. I know this is 1 plus sine A over cos A. Then this is divided by 1 minus sine A over cos A. This is not like double division in one. It's like the top divided by the bottom. So we work the top, the LCD, it's cos A. So I must have cos A over cos A here. Also here, I must have cos A over cos A. All right. And then this will then be cos A plus sine A over cos A. Now this is divided by cos A, which is the down part, minus sine A over cos A, which this is cos A plus sine A divided by cos A multiplied by cos A over cos A minus sine A. Remember, when you change the multiplication, you swap. Now this will cancel that, and then at the end you're left with cos A plus sine A over cos A minus sine A, which is the same as your right hand side. So likely here, you didn't have to do both sides. And then that will be where the part 2 ends. And then part 3, we are going to do more advanced, like we are going to the higher level. So that will be in your part 3. So for the next activity, remember you already done number 1, number 2, and number 5. So you're going to do number 3, you're going to do number 4, you're going to do number 5, let me just give you 3 sums. Just do number 3, number 4, and number 5.